Hello my dear students, welcome to Diksha Karnataka YouTube channel, and in your PUC 1 exam is near, so we are bringing you all the contents required for you to score 60 plus marks in your upcoming final exam. Now today I am going to discuss very important portion of that is the physics model paper. This year PUC board has not released any model paper for PU1, so we are going to solve the model paper released last year, and but don't ignore model paper, because many colleges, many teachers do prefer questions given in the model paper, and that is like a guideline to them, and they follow the model paper pattern, and in many cases the exact questions do come. So do not ignore model paper. Model paper is going to be very, very important for all of you, those who are appearing for final exam. So let's start. Obviously model paper means we will start with the MCQs first, then fill in the blanks, 2-3 markers, and 5 marker derivations and 5 marker numericals. Everything will be completed in this one video, so don't go anywhere, wait till the end, and you will be definitely be able to score more than 60 marks if you watch this video. Let's see. This video and all the other videos that we have done, only not based on this video you cannot score 60 marks, but yes, if the college decides to that, I will give questions from model paper, which is 90% of the cases according to the last year's observation. So you will get a very good chance of scoring 40 plus marks at least from the model paper video alone, so don't skip it. The SI unit of plane angle is, so plane angle's SI unit is radian. So SI unit of plane angle is radian. It is not steradian. Steradian is for solid angle. So this is solid angle. And these are not SI units, okay? Degrees and per degree, whatever it is mentioned, these are not SI unit. SI unit of angle is radian. For solid angle, SI unit is steradian. So do be mindful about it. If they change the question by changing plane to solid, then it will be steradian. If it is only plane angle, then it will be radian. Next, a rectilinear motion is a motion along a circular path, along a plane, along a parabolic path, along a straight line. Rectilinear means straight motion, straight line motion, motion in one dimension, motion in a straight line. Okay, so everything is same. So rectilinear motion means motion along a straight line. A vector is multiplied with a negative integer, the direction of the resultant vector. So suppose we have a vector, say a vector, which is in this direction. Now if you multiply the vector with a negative integer, say minus n, okay, integer is generally represented by number n, so minus n into a vector will represent the same vector but in the opposite direction, and the magnitude will be n times more. So it will be opposite to the initial vector. The direction reverses because the term that you are multiplying is negative, so the direction reverses. A large force acting on a short time to produce a finite change in momentum is called impulsive force, frictional force, viscous force, normal force. The force is called impulsive force, and force into the time duration is called impulse, which is basically gives you the change in momentum. Okay, now next, two vectors A and B are acting at an angle of theta. The scalar product between them, scalar product means dot product. Dot product is obviously A dot B equals to AB cos theta. Okay, A cross B equals to AB sin theta is vector product, and A dot B is equal to AB cos theta is the scalar product. So this is vector, this is scalar, these two are incorrect. Next, before going into next question, I just want to remind you that if you are watching our channel for the first time, then one thing that you must do is to subscribe our channel, and second thing that you have to do is join our WhatsApp channel. The link of the WhatsApp channel given is the description in the video. There you will get all the PDFs, including the long videos that we have done, and this model paper solution PDF as well. So if you want to download those PDFs, and if you want to connect with us and whatever videos that we are doing, whatever updates that we are doing, if you don't want to miss on that, then definitely join our WhatsApp channel. Through there we do the communication mainly, right? So WhatsApp channel, first of all subscribe, second of all join the WhatsApp channel. Now let's continue with our questions. the analog of mass in rotational motion is. So analog of mass in rotational motion is moment of inertia. Moment of inertia is analog of mass. Okay, angular mass, there is no such term called angular mass. Momentum itself is linear motion. Center of mass again is only the center where all the mass is located. So these three quantities are wrong. Moment of inertia is correct. Sometimes they might give you angular momentum to confuse you. Angular momentum is rotational analog of momentum, not mass. And rotational analog of mass is moment of inertia. So whatever role mass plays in linear motion, moment of inertia plays the same role in angular motion. Acceleration due to gravity, small g, decreases with height, increases with height, increases with depth, independent of height. So acceleration due to gravity as you are moving up decreases, as you are going down also decreases. Acceleration due to gravity is strongest and maximum on the surface of the earth. Okay, so it decreases with height is the correct answer. Poisson ratio is the ratio of longitudinal stress to longitudinal strain, volume stress to volume strain, lateral strain to longitudinal strain, longitudinal strain to lateral strain. Okay, so Poisson ratio is basically either option C or option D. Okay, it is not stress by strain relation, it is the ratio of two strains. Okay, remember it is longitudinal bilateral. Okay, longitudinal bilateral is the Poisson ratio, so option D is correct answer. Next, the resistance to the relative motion between layers of liquid is called so resistance when the one liquid is trying to move over another liquid. Okay, so the force that is basically stopping the layer from motion is viscosity. It is called viscosity. Okay, surface tension is basically the on the top of a liquid surface, the surface try to stay in a particular shape, that is surface tension. Friction is the same role that is plays in linear motion on the solid surface. If it is happening in solid surface, then it is friction. If it is happening between liquid surface, then it is viscosity. The column 1 is the list of modes of heat transfer and column 2 is the list of transport media. Identify the correct match. Conduction, convection and radiation. Let's see, fluid, no medium, solid. So radiation requires no medium, so radiation is matching with no medium. Convection happens only in fluid, convection happens only in fluid, conduction happens only in solids. So A is matching with C. So if you see the matching, A is 1 is matching with C, so 1 is matching with C, 2 matching with A and 3 is matching with B. So correct match is option C. Very easy. Next, first law of thermodynamics is equivalent to law of conservation of charge, law of conservation of linear momentum, law of conservation of energy, law of conservation of angular momentum. We all know first law is law of conservation of energy. Next, at constant temperature, pressure of a given mass of a gas varies inversely with its volume. This is the statement of constant temperature, pressure and volume. Pressure and volume means Boyle's law. Pressure and volume means Boyle's law. Okay, temperature and pressure, I think Charles' law. Kelvin's law, I don't think there is something called Kelvin's law. Gay-Lussac's law is in chemistry. Okay, Boyle's law and Charles' law. PV is equal to constant, that is Boyle's law, and that is basically comes from the fact that pressure is inversely proportional to volume. The circular motion of a particle with a constant speed is periodic and oscillatory, periodic but not oscillatory, oscillatory but not periodic, neither periodic nor oscillatory. So when a circular object in a circular motion, okay, definitely it's, if the speed is constant, then it's a periodic motion. Period means after certain time it repeats. After certain time it repeats again and again. That's why it is a periodic motion. Oscillatory motion on the other hand, it has to oscillate around a mean position, and whenever it goes to some point, there will be a restoring force acting towards the mean position. So in case of rotational motion, you don't see that kind of restoring force, you don't see a kind of to and fro motion where there is a mean position. So circular motion is only periodic but not oscillatory. It's periodic but not oscillatory. Next, the minimum distance between two two points on a wave having the same phase is called wave number, wavelength, wave speed, wavefront. So minimum distance between 2 points, minimum distance between 2 points having same phase difference is basically the wavelength. Okay, so this is the wavelength, not wavefront. Okay, wavefront is the locus of points having same phase. Okay, but minimum distance between 2 points having same phase is wavelength. Next, following are the two statements about the vibration of air column. When an air column with one end closed vibrates, node is formed at the close end. So when you are having one end closed organ pipe, what happens is that you see there is a node happening. So node means no vibration because it is a closed end. So there are no particles that can vibrate. That means there has to be a node. So the closed end will always have a node. Okay, at the closed end, pressure changes are the largest while displacement is 0. So if you see that pressure change is largest here, okay, at the antinode where the pressure changes maximum, but yes, node can also be seen as pressure change is maximum, but anyway displacement is 0 is correct, and that is why pressure changes is largest here as well as here. Both positions pressure change is largest. Okay, because here the variation is maximum, here variation is minimum. So that means here also highest pressure, here is the lowest pressure. So variation can be highest, can be lowest. So here the pressure is highest, here the pressure is lowest. Okay, so pressure change is maximum, okay, correct, and while the displacement is 0, obviously displacement is 0, that's why it is called a node. Okay, so both 1 and 2 are true, and 2 is the correct explanation of 1. So option A is correct. Why it is the correct explanation? Because of the displacement is 0, that is the reason behind it's forming a node. If displacement is there, it will not be a node. Okay, if displacement was there, then it will not be a node. So in this case, this pressure difference is maximum, but displacement is also maximum. So that is antinode. If pressure difference is maximum and displacement is 0, then it will be a node. Next, let us move into the fill in the blanks. Thermometer, elastic. Okay, let's see the option. No point of reading the options without reading the question. In pure translational motion at any instant of time, all particles of the body have the same. Pure translational motion at any instant of time, particles of the body have the same thermometer, elastic, velocity, mean, pressure, calorimeter. So it has to be same velocity. Pure translational motion means all particles should have the same velocity. A device used to measure heat. Device used to measure heat is calorimeter. So correct answer is calorimeter. In an isobaric process, the quantity that remains constant. Isobar means pressure. So baric pressure, isobaric means pressure is constant. Okay. So excuse me. According to the kinetic theory, all oscillations between molecules of an ideal gas are, so according to the kinetic theory, collisions between all molecules in the ideal gas are elastic. Let's see, elastic is there. Yes, elastic is there, so it will be elastic. In simple harmonic motion, the restoring force always directed towards the mean position. So obviously thermometer cannot be the option for this, so only mean position can be the answer. So mean position should be the answer. So if you are having trouble in answering fill in the blanks, then what you should do, you should at least try which of them you can answer. Okay, once you are done with them, make sure that your options makes a logical meaning. Obviously if you put thermometer over here, that does not make any sense, right? Always directed towards the thermometer, that does not make any sense. So make sure that options are making some sense. Okay, thermometer or calorimeter can be used over here. Now heat is measured by calorimeter, temperature is measured by thermometer. So only one question where there is a confusion, otherwise all the options are self-explanatory. So even if you are not sure what would be the answer, check in the options what is left and which of them you can use in that particular case, right? That is the trick to answer fill in the blanks. Now next, write any two applications of dimensional analysis. So checking the dimensional consistency of equations. For an equation to be dimensionally consistent, the dimensions on both sides should be same. So that means if you are writing say A equals to xy, then what is the dimension on the left hand side should be the same of the dimension on the right hand side. Dimensionally it should also be valid. Deducing the relationship among physical quantities, how and which are the fundamentals quantities are involved in a physical quantity can be determined using dimensional analysis. For example, if I say that time period of oscillation is proportional to square root of L by G, this formula can be derived using dimensional analysis. Any constant involved cannot be determined, but how they are related to with the quantities, that can be determined. Constant involved cannot be determined. Next, what is meant by free fall? What is the direction of acceleration of free fall? Free fall is the motion of an object under the influence of gravity alone with no other forces acting on it. Okay, so when an object is allowed to fall without having any other forces, any other resistive forces acting on it. For example, if I drop this pen, okay, it will start falling, but there is a resistive force of air acting on it. Okay, so if you can ignore the air resistance, then it will be a free fall. If you can produce something where it is absolutely vacuum, no force is there, then you can say this is a free fall motion. The direction of acceleration is downwards. Direction of acceleration in free fall is always downward. Falling means it is falling, right? So that means it is the acceleration's direction always in the downward direction. Write the expression for centripetal acceleration and explain the term. So what is the centripetal acceleration? Centripetal acceleration is given by Fc equals to mv square by r. Okay, and centripetal acceleration, when does it occur? It occurs only when you are rotating in a circular motion. Okay, suppose an object is moving in a circular motion with a speed v, the radius of the circle is r, okay, mass of the object is m, then centripetal acceleration, I am writing centripetal force. Centripetal acceleration means only v square by r. Okay, centripetal acceleration is only v square by r. Centripetal force will be mv square by r. Okay, so now what is v? V is the speed. Now we will use speed because it's a circular motion, so direction of velocity changes every time. So we will use speed of circular motion, and r is the radius of the circular path. Right? Along with this, if you draw the diagram, you should get the full marks. 2 marks is there, but anyway, easy question. If you draw the circle along with this notation, what that harms you? Okay, so you will be much more better established in towards your teacher, that they will think, okay, student knows the concept. Next, write any 2 methods of reducing friction. Very important question. Lubrication, applying substances like oil or grease between the surfaces helps to reduce the friction by creating smooth layer that allows them to slide more easily. Using ball bearings reduce friction in machines by replacing the sliding motion by circular motion or rolling motion. Next, state 2 conditions under which a force does no work. Okay, so first is displacement is 0. So what is the expression for force? Is basically work done is given by Fx cos theta. So suppose we are moving in this direction. So this is say direction of displacement, this is the direction of force, this angle is theta, then work done is given by Fx cos theta. Now in which case work done by a force can be 0? Obviously work done by a force can be 0 means F is not 0. So either x is 0, either x equals to 0 or cos theta equals to 0. Both cases work done will be 0. So when x is 0, that is the object does not move under the influence of a force. Suppose this is the object, I am applying a lot of force on this, but the board is not moving. That means the work that I am doing on this board is not doing any work, so work done is 0. The force and displacement are perpendicular to each other. So if force and displacement are perpendicular to each other, then the angle is obviously 90 degrees. So if the angle is 90 degrees, then we say the work done is 0, cos theta is 90. 90, cos 90 is 0. A structural steel rod has an area of cross section of 3.14 into 10 to the power of minus 4 meter square and a length of 1 meter. 100 kilonewton force stretched it along the length. Find the stress on the rod. Okay, so you have to find the stress of the rod. Now in this question the Young's modulus should have been given. Okay, Young's modulus is not given, so you cannot solve it without knowing the Young's modulus. Okay, sorry, my mistake. They are asking you only find the stress. Find the stress, not strain, sorry. So stress is given by, not the strain, my mistake. So you have to find the stress. Stress is force divided by area. Sorry, my mistake. Stress is force divided by area. So force given here 100 kilonewton and the area is given by 3.14 into 10 to the power of minus 4. So that will be 1 by 3.14 into 10 to the power of 6. Okay, so that will be the stress. You can use a calculator to calculate the value. Approximately it will be 10 by 3.14 into 10 to the power of 5, that is 3 3s are 9. So approximately 3 into 10 to the power of 5 kilonewton or Newton per meter square. This is the stress. Stress is basically same unit as pressure. Stress and pressure are same. Now remember, if you are solving these questions, make sure you are using the units and having the proper unit will give you the full marks. Next, state the law of equipartition of energy. Give the number of degrees of freedom of a monoatomic gas molecule. Okay, so law of equipartition of energy states that in thermal equilibrium the total energy of a system is equally distributed amongst all the degrees of freedom. Each degree of freedom contributes half kBT, where kB is the Boltzmann constant and T is the temperature in Kelvin or absolute temperature, okay, to the average energy per molecule. So if there are, say, a molecule having n number of degrees of freedom, then its total energy will be n kBT. That's it. That is equipartition of energy. Okay, degrees of freedom of a monoatomic gas is 3. Degrees of freedom for a diatomic gas is 5. For triatomic it is slightly complicated. Based on the configuration it can be 7, it can be 6 as well. Okay, now let's move on. Write any two differences between longitudinal and transverse wave. Okay, so longitudinal waves, particles vibrate parallel to the wave's direction of propagation. Transverse wave, particles vibrate perpendicular to the wave's direction of propagation. Example, sound wave is in air, water waves, light waves, they are example of transverse waves. Easy question. Derive the kinematic equation V is equal to V naught plus AT using VT graph. Okay, where the symbols have their usual meaning. So first of all you have to draw this graph where you have to show that this is the initial velocity V naught and after some time t the particle is accelerating with acceleration a and reaches the point B. Then after time t the new velocity is V. So everything has to be clearly mentioned, V naught, V, time t. Okay, you can highlight the area even though area is not required. The upper triangle is sufficient for this particular problem. Okay, now what is acceleration? Acceleration is rate of change of velocity, and from VT graph we know that first of all graph is plotting is compulsory because they are asking you to using VT graph. So if any question is being asked to you using VT graph, then the VT graph drawing is compulsory and you get 1 marks. If you don't draw the VT graph you will get 0 marks. No matter even if your derivation is perfectly correct, you will get 0 marks if you don't draw VT graph. Okay, we know that the slope of a Vt graph gives the acceleration, right? So what is the slope of this graph? Slope of a graph is given by change in y direction divided by change in x direction. Okay, here y direction is v, x direction is t. So if you consider from here to here, the change in y direction is v minus v naught. So acceleration is m, slope, the change in y direction is v minus v naught. Okay, final minus initial. And what is the time difference? Time difference is t. So this is the acceleration t. Okay, so from here you just cross multiply. At equals to v minus v naught, or v equals to v naught plus at. Very simple, easy derivation. Okay, nothing, no rocket science. Only thing that you have to be careful about, the slope gives, this term has to be mentioned. The slope of velocity time graph gives you the acceleration. So this has to be mentioned, otherwise this derivation has no meaning. Okay, so you have to mention that slope of a velocity time graph gives you the gives the acceleration, and here slope is delta y by delta t, delta y by delta x. In this particular case it is delta v by delta t. Okay, obviously delta v is v minus v naught, delta t is t itself. Now let's move on to the next part. Define equal vectors, unit vectors and null vectors. Equal vectors, two vectors are said to be equal if they have same magnitude and same direction regardless of their initial position. So for example, if a 3, 4 and b 3, 4, then both of them have a equals to b. Position vector, we are talking about position vector over here. Okay, so 3, 4 means obviously this is the a 3, 4, 3, 4. Okay, so this is a position vector of 3, 4. B is also the same point, then definitely they are equal vector. Unit vector, unit vector is a vector that has a magnitude of 1 and points in a specific direction. It is used to indicate the direction only. Okay, a unit vector a cap in the direction of a vector a is given by a cap equals to a by modulus of a. Null vector, a null vector or zero vector is a vector with a zero magnitude and no specific direction. It is represented as phi. Okay, so for example, why we use zero vector which has no direction, no zero magnitude? Because in many cases when two vector quantities are basically being added or multiplied, we get a result which is a vector quantity but the magnitude is zero. For example, if I say a vector minus a vector, so it is a subtraction between two vector quantities, so definitely the resultant should be a vector quantity, but we have no idea to say what is the direction and what is the magnitude is zero obviously, but what is the direction we are not sure, but the final quantity is a vector quantity, that much we know. So that is an example of null vector. Another case it occurs when we are having a cross product of two vectors, say v cross v, both are having same direction. When you are cross producting two same vectors, the resultant is a null vector because it has zero magnitude, but still it is a vector quantity. Okay, but direction we are not sure of, so those are called null vectors. Okay, next, using Newton's second law of motion, derive force equals to ma, father equals to ma. You have to prove that your father and mother are both same, where symbols have their usual meaning. So what is Newton's second law of motion? Newton's second law of motion states that force is proportional to rate of change of momentum. Force is proportional to rate of change of momentum. Now I guess at this stage you are equipped enough to answer this question using differentiation method. Differentiation method is short, easy and not complicated. Okay, so force is directly proportional to rate of change of momentum, that is second law. So you have to write from second law, we can write From second law, we can write F is proportional to dp by dt. Now momentum is given by mass into velocity. Okay, momentum is given by mass into velocity. It is a vector quantity. Now we have to put this value back at over here. So F is proportional to d dt of mv, or F is proportional to mass is a constant, so mass will come out and we get dv by dt. Or what is dv by dt? So F is proportional to m into a. So here dv by dt is rate of change of velocity, that is nothing but acceleration. Okay, or F equals to k into ma. Now many students, what they do, they put k. Now let us put, there is one textbook also which say let put k equals to 1, then F equals to ma. So if I let means you are imagining that k equals to 1. So if you say let k equals to 1, so suppose I am saying let k is equal to 1000, so F is equal to 1000 ma. So I can let anything. So you cannot let k equals to 1. So if you are using someone who is writing let k equals to 1, stop doing that. So now you have to mention that the unit of force is defined such that if m equals to 1, a equals to 1, then F will be also equals to 1. So this line is very essential. If you just let k equals to 1, the teacher might give you maybe 1 mark for doing this much hard work. Okay, if I am the examiner, I will give you 1 mark, maybe 0 as well, because you cannot take let k equals to 1. There is a book, a very substandard quality of book that says let k equals to 1. That is very popular among the students because the book is very thin, and there it is written completely wrong. Do not do that. You cannot take let k equals to 1. You have to mention the unit of force is defined such that if m equals to 1, a equals to 1, then F equals to 1. So we get, therefore K will be equals to 1. It is coming from the definition of unit of force. It is not coming from let or say or put. It is not coming like that. Okay, it is only coming because when m equals to 1, a equals to 1, then K is also equals to 1. K is a proportionality constant. You cannot take any arbitrary value for a proportionality constant. Okay, therefore F equals to ma. So when you are proving father equals to ma, you have to put some respect on this, right? You cannot say just because I want F equals to ma, so I am doing putting k equals to 1. You cannot do that. You have to show why k equals to 1. This one line can change this answer from full marks to more less than half of the marks. Now let's move on. A woman draws a bucket full of water weighing 10 kg from a well, which water level is 8 meter below in 9.8 second. Find her average power. Take G is equal to 9.8 meter per second square. So let us understand. So a woman, she is drawing water from a well. Okay, so this is the well. So she is standing over here. She is standing over here and she is putting her bucket. Okay. So I think many of you have seen the water, that how it is being drawn. So this is how the water is being drawn from the well. Okay, and the weight of the water, bucket full of water, is 10 kg. So mass is given 10 kg. Okay, the level is 8 meter below. So this is 8 meter below. Okay, now what is the weight that the woman is moving? The weight of the water is basically m into g. and when you are pulling something up, basically what work you are doing, you are doing work against the gravity, and that means this is basically your force. Okay, gravitational force is mg, that against that force you are doing the work. So what is the let's not write this as W, because work done is written as W. So force is basically mg. So what is work done? Work done is given by force into displacement. Force into displacement is the work done. So here the displacement is obviously m is 10, m is 10, g is 9.8, and displacement is 8. Displacement is 8 meter. So this is the work done by you. This much work that is done by the woman, not by you, done by the woman. So you have to find the average power. So average power is basically work done divided by time. Average power is rate of work done. So rate of work done means 10 into 9.8 into 8 divided by 9.8 second, because the time taken by her is 9.8. So 9.8 cancels and you get 80 watt. So the work power of the woman is 80 watt. What is meant by equilibrium of a rigid body? Write the conditions for equilibrium of a rigid body. A rigid body is said to be in equilibrium when it remains at rest or moves with constant velocity under the influence of external forces. This means that there is no net force or torque acting on it. So net force and net torque both should be 0 for us to say that a rigid body is in complete equilibrium. Conditions for equilibrium: translational equilibrium, the sum of all the external forces acting on the object should be 0. Rotational equilibrium, the sum of all the external torques should also be 0. So conditions and equilibrium obviously means that object is basically no net force is acting on it, okay, and condition is net torque is 0, net force is 0, obviously. Now let's move on. State 3 Kepler's law of planetary motion. First law, law of orbits. Every planet moves in the elliptical orbit around the sun, with the sun at one of the foci of the ellipse. Kepler's second law: add a line segment joining a planet and the sun sweeps the equal areas in equal interval of time. Kepler's third law: the square of the orbital period, time period t of a planet is directly proportional to the cube of the semi-major axis of its orbit. Very important and very common as well. What is meant by streamline flow and turbulent flow? Write equation of continuity for a fluid flow. So in streamline flow, the fluid particles move in a parallel layers without mixing. Each particle follows smooth, well-defined path. In turbulent flow, fluid moves in an irregular and chaotic manner. So the motion is very, very chaotic. Normally, whatever motion we observe are basically turbulent flow. Okay, streamline flow is very rare. Characteristic by swirls, vortex and mixing of fluid. So if the fluid is flowing very cleanly and perfectly, then it is called a streamline flow. You may have seen some videos where some water is being flowing and it appears to flow, but actually it is not. It is almost static. It is appearing that water column is just static, but if you put some hand under it, you feel the force. So that is basically a streamline flow. Otherwise, if you can see the motion of water falling from a tap or anywhere, basically that is a non-streamline motion. Okay, an equation of continuity: suppose we have a pipe from which the liquid is being flown. Okay, suppose the area here is A1, velocity of the liquid is V1, here the area is A2, velocity is V2. Then equation of continuity is A1 V1 equals to A2 V2. So for this the diagram is compulsory. When you are writing equation of continuity, the diagram is compulsory. Next, show that the volume coefficient alpha V equals to 1 by T for ideal gas, where T is the absolute temperature of the ideal gas. So volume coefficient of heat or volume coefficient of expansion is given by alpha V is defined as 1 by V dq by dt. Sorry, not dq, dv by dt. So what is the volume coefficient by the way? Volume coefficient means you apply some heat to a gas, its volume changes, its temperature changes. So the rate of change of volume with temperature divided by its original volume, that is the volume coefficient. Okay, so volume coefficient is change in volume with respect to temperature divided by its original volume is the volume coefficient, right? Now we know that PV equals to RT. We are assuming 1 mole gas, so no need to worry about mu or N. Okay, so just keep it V is equal to RT. Now differentiate both sides with respect to temperature. Now obviously if I am talking about volume coefficient, pressure has to be constant. So pressure constant. So if you are because if you change pressure, volume will change automatically. So when you are finding volume coefficient, pressure has to remain constant. So dV by dt equals to R, right? dV by dt equals to R, right? Differentiate both sides. So here you get the factor, here R is constant, dt by dt is 1, right? Differentiation we have learned it. So dV by dt equals to R by P. So let's put that back in this equation. So alpha V equals to 1 by V R by P, or it is R divided by PV, or R divided by RT, right? PV is equal to RT, so R cancels and we get alpha V equals to 1 by T. So basically volume coefficient of a gas does not depend on its volume, does not depend on its pressure, it only depends on its absolute temperature. Next, illustrate the conservation of mechanical energy in case of a body dropped from a height h. This is a 5-mark derivation from the chapter work energy power. Here we have an object which we have dropped from, say, at a height, this is ground, from a height of capital H. Okay, now in this case 3 positions you have to show, and you have to show that the total energy in each and every step is constant. So when you are dropping it from this position, its velocity at this position, velocity is 0, okay, and its height is obviously maximum h. Now it is allowed to fall at some height and it reaches at some intermediate height where you are saying that the height at this position is small h. Say the velocity is given by u. Velocity at this stage is, say, u, or say, okay, so velocity at this position, say, don't say u. So this is our position number 1, this is our position number 2, okay, velocity at this position, say v2, and when it reaches the ground, obviously the height is 0 and velocity, say, v3. This is our third position. Now you have to show that each and every position the total energy is constant. So when it is at the topmost position, it is just being dropped, so no initial velocity. So what is the total energy of this object? The total energy of, or total energy at position 1, at position 1, total energy T is actually its potential energy U. Total energy equals to potential energy. What is potential energy? Potential energy is mgh. Total energy is mgh. Now when you allowed it to fall, okay, when it reaches this, now what is the acceleration of fall? Acceleration of the fall is g, okay, it is falling with an acceleration g, okay, and how much distance it traveled? The distance it traveled is, obviously, this is the displacement, that is h minus h. So distance traveled is h minus h. So for position 2, see, position 1 and position 3 are simple. Position 2 is the most difficult one. If you can handle position 2, you can handle position 3 as well. Okay, so at this position there is a kinetic energy, there is a potential energy as well. So what is potential energy at this position? Potential energy, this is T1 U1. Okay, potential energy at this stage is mg into small h, mg into small h. Potential energy is easy, so let us handle that first. So it is at a height of small h, so potential energy will be mg small h. But we have to find the kinetic energy. To find kinetic energy, what is kinetic energy? Kinetic energy at this position, kinetic energy was 0. Okay, so what is kinetic energy here? Kinetic energy is half m v2 square. But we have no idea about v2. So what we have to do, we have to use this gravitational acceleration, we have to use this displacement and initial velocity 0 to calculate v2. Okay, what equation? V equals to u plus 2as. Okay, here s is the displacement is this one. So understand this, first stage you have to show 3 positions. First position, top position, entire thing is potential energy. So entire thing is potential energy means mg capital H. In the second position, okay, potential energy is easy. Potential energy, assume the height is small h, so potential energy will be mgh. Kinetic energy is tricky. Kinetic energy you have to calculate the velocity. So how to calculate the velocity? Equation of motion, where displacement is known, gravitational acceleration is known, so v2 is simply given by v2 equals to 2gh minus small h, sorry, v square equals to u square plus 2as, okay, v square is equal to u square plus 2as. So v square value we have calculated, so we can calculate the kinetic energy 2 as well. So kinetic energy 2 is given by half m into 2g small capital H minus small h. So 2 cancels and you get mg capital H minus small h. So what is the total energy now? Total energy at position 2 has to be the kinetic energy plus potential energy. So that is, kinetic energy is given by mg capital H minus small h, and potential energy is given by mg small h. So if you add them, you get mg capital H. So second position is also calculated. Now we have to calculate the same thing for position 3. For position 3. So how to calculate for position 3? To calculate the energy for position 3, we have to use that the entire object now has moved by a height of capital H. Initial velocity was 0, final velocity is v3. So obviously potential energy at this position is 0 because it's reached the ground, so height is 0, so potential energy is 0. Kinetic energy is given by half m v3 square. So what is v3? Same formula we will be using. v3 square equals to 0 square plus 2 g into capital H. Now displacement is capital H over here. Initial velocity was 0. The entire object has reached the distance capital H. So v3 square equals to 2gh. So kinetic energy K3 is half m into 2gh, that is mgh. So what is the total energy? Total energy T3 is equals to K3 now, and that is equals to mgh. So we see that T1 equals to T2 equals to T3 equals to mgh. So the total energy of a falling object is constant. Okay, so the conservation energy is conserved for a body dropped from a height. So energy of a falling object or an object which is being dropped is constant throughout the motion. Okay, so this is a very important derivation. If you want to practice it, you have to practice 2 times, but it is an easy, simple derivation. Only trick is for position 2, how can you find velocity. If you know that this is the displacement, okay, then you can solve any kind of problems. Next, define torque and angular momentum. Derive the relation between torque and angular momentum. So torque is the rotational equivalent of force. It is the moment of force about a point or axis which causes the object to rotate. Torque equals to R cross F. Angular momentum is the rotational equivalent of the linear momentum. It is the measure of the rotational motion of an object about, and it is given by R cross P. So torque is R cross F and L is R cross P. Now derive the relationship between torque and angular momentum. Okay, so we know that what is angular momentum. We will start with angular momentum. Angular momentum is R cross linear momentum. Okay, and what is linear momentum? Linear momentum is mass into velocity. So what we can say, angular momentum is mass into R vector into V vector, right? One more thing, torque is given by R cross F. Okay, R cross F. Now what is R? What is F? F is actually rate of change of momentum. F is actually rate of change of momentum, that is dp vector by dt, right? So it is basically rate of change of momentum. Now if you put R cross d dt of mv vector, obviously m is constant, so it will come out R cross dv dt. You can leave it over here, no need to convert it into acceleration and show it. You can leave this part over here for now. Now we have to differentiate both sides here. So dl by dt. Okay, dl by dt. So everything you have to know over here. So m is constant, d dt of R cross V. So here we have to do differentiation by parts. You may not aware of this, but anyway I will teach you. So first what you have to do, you have to keep one thing constant. On the right hand side, whatever is there, that thing we have to keep constant, and we have to differentiate the first term. So dr vector by dt cross v vector, and then plus, okay, constant will be same. Now you keep the first term same and you differentiate the second vector. Okay, you keep the first term same, differentiate the second vector. So first step is to keep the second term same, differentiate the first vector. Second step is to keep the first term same, differentiate the second quantity. Now what is dr by dt? Dr by dt is the rate of change of displacement. So rate of change of displacement is nothing but m velocity into velocity plus m r vector dv cross dv by dt. Now if you cross product to same vector, that gives you a zero quantity because they are in the same direction. Okay, v vector and v vector, both, if you take two same vectors, if you do a cross product, the sine theta is 0 between them. So because sine theta is 0, cross product means sine theta, so theta 0 means sine 0 is 0, so cross product will be 0. So that means this quantity is 0. So we can write m r vector cross dv by dt. So this is our equation number 2, this is equation number 1. So if you compare these two equations, equations 1 and equation 2, comparing 1 and 2, we see that right hand side is same, so left hand side must be same. So torque must be equals to dl by dt. Okay, so this is the relationship between torque and angular momentum. So force is rate of change of momentum, torque is rate of change of angular momentum. Force is something which makes an object to move, torque is something which makes an object to rotate. So that is the fundamental difference. Now next question, derive an expression for escape speed from the surface of the earth. So suppose we have an object which is located on the surface of the earth. We have an object which is located on the surface of the earth. At this position, the mass of the earth is capital M, the radius of earth is capital R, okay, the mass of this object is small m. So what is the gravitational potential energy of this mass? The gravitational potential energy of mass m on the surface of the earth. What is the formula? Gravitational potential energy is minus gmm by only the distance, no square over here. Okay, in gravitational potential square is not there, similar to that of gravitational force, but it is only 1 and minus sign is there. Now once this object leaves earth, then when the object goes to infinity, okay, when the object goes to infinity, after exiting the earth, after escaping to infinity, the potential energy U infinity equals to 0. When the object goes to infinity, potential energy will be 0. So what is the change in potential energy? Change in potential energy is U infinity minus U on the surface of the earth, say UR, and that is equals to 0 minus gm by r, so it will be gm m by r, positive value. Okay, now if you want to give it a velocity of ve to escape the earth, if ve is the escape speed, then kinetic energy is half m v square. So the minimum velocity that you give to escape the earth, that should be equals to this change in potential energy. So kinetic energy must be equals to change in potential energy. So half m v square equals to gm small m by r. Now m cancels and you get v square equals to 2gm by r. Okay, or you can write this as 2gm by r square. Sir, you are doing a cheating, you are bringing square, but there was no square. So don't worry, so we will multiply one above, right? Because we have added one r in the top division, so we have to multiply one in the multiplication as well. So gm by r square is basically our what? Gravitational acceleration. So v square into 2gr, okay, g equals to gm by r square, right? Or escape speed is square root of 2gr. If you put all the values of gravitational acceleration, if you put the value of radius of earth, it turns out to be 11.2 kilometer per second. Kilometer per second, not hour, okay? 11.2 kilometer per second is approximately that much speed is required for something to escape the gravitational acceleration of earth. Next, state and explain zeroth law of thermodynamics. Write 3 differences between isothermal and adiabatic process. Along with this, they might ask you that what is zeroth law and explain the concept of temperature from it. That also you can prepare. Okay. Statement, because this question is given in your model paper, I am solving that. How the concept of temperature comes from zeroth law, that can also be asked as a 5 marker as well as a 3 marker question. Statement, if two systems are each in thermal equilibrium with a third system, then they are in thermal equilibrium with each other. Suppose we have three bodies A, B and C. If A is thermal equilibrium with C and B is also in thermal equilibrium with C, then A and B must also be in thermal equilibrium with each other. So the diagram they have generally draw is like this. So this is A, this is B and this is C. So A and B are not connected, so they are thermally insulated. So A, B and C, so they are not exchanging any heats. B and C is also not exchanging any heats. Then if you remove them, if you bring A and B together, they will also not exchange any heat. And from there the concept of temperature comes, that says that because if there is a temperature difference, two objects exchange heats. Because they are not exchanging any heats means they has to have in the same temperature. Anyway, now the difference between isothermal and adiabatic process. Definition: a process in which the temperature remains constant is called isothermal. Adiabatic process which no heat is exchanged with the surrounding is called adiabatic. Heat is exchanged with the surroundings to maintain the constant temperature. No heat is exchanged, all energy changes occur due to the work done. Okay, in equation PV equals to constant, and adiabatic process equation is PV to the power of gamma equals to constant. Okay, very easy. Now next, with a schematic diagram showing the components of restoring force, derive an expression for the time period of an oscillating simple pendulum. So this can be tricky. So here we have a simple pendulum which is oscillating. Okay, now here you have to do what exactly I am doing. Okay, there is no other option for you to solve it. So here the mg of the object acting downward. Suppose this angle is theta. Okay, now here what happens is that you have to take, this is the tension T. You have to take two components of mg. You have to take two components of mg, not the components of tension T. So one component of mg you have to take in this direction. Okay, and if this angle is theta, so they are similar angles, so this angle will also be theta, so this will be mg cos theta, and this one will be perpendicular to the, so this is the motion. Okay, so this will be the perpendicular component, this will be mg sin theta. Okay, because it's rotating like this, so you have to trace the tangent, not this direction. Okay, not this direction, that direction is not important, this direction is important. That's why we are using mg and not the tension. We are using mg and not the tension. Let me use a separate color. Let me use this color. Okay, this is mg sin theta. Now if you see that which component is responsible for the restoring motion, the component which is responsible for restoring motion is mg sin theta. So this T and mg cos theta will be equal. T will be equals to mg cos theta. Okay, so T will be equals to mg cos theta. So tension will be balanced by this component of weight, and mg sin theta will provide the required restoring force. Okay, mg sin theta will provide the required restoring force. Now if you take the length of this as capital L, then what is the torque required to keep this simple pendulum in motion? The torque required is, or the torque acting on this simple pendulum is the force, that is mg sin theta, and the distance which is L. Okay, the torque, the magnitude of torque is given by mg sin theta into L, R cross F. So R is L and F is mg sin theta. Okay, cross product we are not doing because anyway we are taking the scalar multiplication. So mg sin theta into L gives you the torque acting on this simple pendulum bob of the simple pendulum at this particular moment. So if you know the torque, we also know that torque is same as force but in rotational motion. So torque can be written as moment of inertia into angular acceleration. Moment of inertia into angular acceleration, and that is equals to mg L sin theta. Okay, or alpha equals to mg L by I sin theta. Now for a object tied to a string or a simple point object which is rotating around a point with a non-extensible massless string, obviously the mass of the string is 0, then I is given by ml square. Also, when the angle of rotation is small, so for small theta, this should be noted that the angle of rotation should be less than 10 degrees, then sin theta can be approximated as theta. Okay, sin theta can be approximated as theta. Theta is taken in radians. Even though I am saying that it is in 10 degrees, the theta is expressed in radians. So I equals to ml square and sin theta equals to theta. Now what about alpha? So alpha will become mg L divided by ml square into theta. Okay, one more thing, it will be minus sign over here. Why minus? Because it is a restoring torque. Okay, restoring torque means it's trying to bring it back to its original position. That's why it's a restoring torque, so it will be minus sign. Okay, don't worry if you forget the minus sign, you can add the minus sign at the last. Okay, so m cancels and you get this is minus g by L into theta. Okay, now if this is the angular acceleration, this is angular displacement. So if acceleration and displacement are related like that, then it is a simple harmonic motion, and in that particular case acceleration can be written as minus omega square theta. It can be for linear motion, it can be for angular motion, all type of simple harmonic motion. If you find such kind of equation, then it is a simple harmonic motion, and that can be written like this. So therefore omega square must be equals to g by L, or omega equals to square root of g by L, and time period is given by 2 pi by omega, or 2 pi square root of L by g. This is the time period of simple harmonic motion. So provided when it is a simple harmonic motion, provided the angle is small, and also we have to use the motion of rotational motion, not simple linear motion. Now we are into the linear numerical portions. A ball projected with a velocity of 50 meter per second in a direction making an angle 30 degree with the horizontal. Find the maximum height and the time of flight of the ball. For what angle of projection the range will be maximum. So last part is 45 degrees. The angle of projection is 45 degrees. The range will be maximum. It is always. And here diagram is not necessary for this particular problem, but you can draw it. So angle of projection is 30 degrees. So the first part you have to find the maximum height. So what is the maximum height? Maximum height is v square sine square theta divided by 2g. Very simple. Put the values. So it will be 50 square into 50 square. Sorry. No, what I am doing, v square is 50 square because v is 50. You should write that given data once. Sine square 30 degrees divided by 2 into 10. Okay, or 50 into 50 G we are taking 10. Sine square 30 means sine 30 is half, so it will be half square divided by 2 into 10. 0, 0 cancels, and we can cancel this also. So we get 25 into 5, that is 125. 125 divided by half square, that is 4. Okay, so it will be 4. So it will be 3 4s are 12, 4 1s are 4.25. So 31.25 meter. You are allowed to use simple calculator. If you are not sure how to find it, use a simple calculator to calculate it. Next is time of flight. Time of flight is V sin theta upon G. U sin theta upon G. So V is 50, sin 30 is half, and G is 10. Okay, so it will be 0, 0 cancels. There is 2V sin theta, sorry, my mistake. So 2V sin theta is there, 0, 0 cancels, 2, 2 cancels, it will be 5 seconds. V sin theta by G is only half time. Total time of flight 2V sin theta. Okay, so now next range will be maximum if theta is 45 degrees. This is always, no matter what is the case, whatever is the problem, range will always be maximum for theta 45 degrees. Next question. A man pushes a car of mass 2000 kg at rest along the horizontal road with a steady force of 300 Newton. The resistance of the road is 0.05 Newton per kg. Find the velocity of the car at the end of 20 seconds and distance travelled by the car. So we have a car. Suppose this is the car. I am not drawing the car, I am just drawing a box. So you are applying some 300 kilonewton force, 300 Newton force, and there is a friction as well. Okay, the mass is 2000 kg, and you have to first find the velocity. Next you have to find the end of 20 second distance travelled by the car. Okay, so how to do that? First of all, you have to find the frictional force. So frictional force is mass times the resistance force. Resistance force here is given 0.05 Newton per kg. So mass is 2000 and it is 0.05 Newton per kg. So that means the unit will be only in newtons, and you get 100 Newton. So frictional force is 100 Newton. You are applying 300 Newton in this direction, frictional force acting in the opposite direction of 100 Newton. So the effective force is force that you have applied minus the force of friction, that is 300 minus 100, that is 200 Newton. So 200 Newton is actually pushing the object or taking the object in the forward direction. Now what do we know from Newton's second law? Father equals to ma, and that is only for effective force. So acceleration is effective force divided by mass, that is 200 Newton divided by 2000 kilograms. So that is 1/10 meter per second square. So acceleration is calculated. Now they asked you calculate the velocity at the end of 20 seconds. So velocity after 20 seconds is given by A into T. So it will be 1/10 into 20, that is 2 meter per second. V is equal to U plus 80. U was 0, so just 80. Okay. Now distance travelled, how to calculate distance travelled? S is equal to 0 plus half AT square. 0 plus half AT square. 0 is U is 0, so that's why 0. So equals to half. A is 1/10 and T is 20, so 20 into 20. So 0, 0 cancels, 2, 2 cancels. So distance travelled is 20 meters. Okay, so speed is 2 meter per second and distance travelled is 20 meters. So very easy problem. If you just know this formula, how to calculate the resistive force, find the difference, then calculate the problem. Very easy problem. Next, The base of a copper boiler is 2 cm thick and has an area of 0.01 meter square. The steady difference in temperature between its face is 5 Kelvin. Calculate the mass of water that evaporates in 1 hour given the thermal conductivity of copper is 385 watt per meter per Kelvin and latent heat of steam is 2.2 into 10 to the power of 6 joules per kg. Now here, what formula I am not going to solve. I have solved this question in my numerical question section, but I will tell you the formula. So mass of the water evaporated times the latent heat of water, okay, that is the amount of heat that is required in 1 hour, and that should be equals to K is this one, okay, the conductivity of copper, area into delta T divided by the distance between the so thickness divided by the distance between the plates, or in this case thickness of the pan, okay, the pan is this much thick. So this is the source of heat, okay, this is the source of heat. Bunsen burner is there, okay, you are burning it here. So this is the source and this is the place where the water is there. So okay, this is the thickness, distance between the 2 points, okay, and into time t, okay. So K is given, A is given, you can calculate mass. So mass of water which is evaporated is given by K A delta. Let me put the values. You can use a calculator to calculate the exact value. Okay, very easy question. It does not only the thing, only you are getting marks for remembering this formula. You are getting marks for remembering this formula. Area is also given in meter square, so no need to convert units. The difference temperature is also given 5 Kelvin, 5 Kelvin, 5 degrees Celsius, does not matter. Okay, now let me write the thickness, not write D. Thickness, let us write in terms of D. Okay, the thickness is 2 centimeter. So 2 centimeter you have to convert it into meters by multiplying 10 to the power of -2. So if you are solving such questions, centimeter to meter, always convert it into by multiplying 10 to the power of -2. That is much easier. And here the time is given as 1 hour. 1 hour means 60 minutes, and 60 minutes, 1 minute means 60 seconds. So you have to calculate this mass by doing this and divided by latent heat. So latent heat, obviously, so latent heat will come on this side as well. So latent heat is 2.2 into 10 to the power of 6. This is also in division. Okay, why we are putting it in division? Because obviously L will go in this direction. Okay, if you are still thinking here, mass is equals to Ka delta T into time T divided by the displacement into latent heat. Okay, so it will be 60 into 60 divided by 2.2 into 10 to the power of 6. Now you will solve it. I think you will get some 1 point something kg. Okay, now next, a string 1 meter long is under the tension of 440 Newton. If the fundamental frequency is 100 Hertz, find the mass per unit length of the string. What is the mass of the string? So fundamental frequency is given, tension is given, okay, then so time period of wave produced in a state string is given by 2 pi square root of T by mu. Okay, T is the tension, mu is the mass per unit length. Okay, and frequency is 1 by time period. So it will be 1 by 2 pi square root of mu by T. Okay, so frequency is given 1 Hertz. Okay, you can calculate mu. Sorry, one mistake I made. It will be time period is mu by T. Time period is mu by T, and frequency will be T by mu. Okay, frequency will be T by mu. So you put the values over here and you calculate that f square 2 pi whole square, 2 pi f whole square equals to T by mu, or mu equals to 2 pi f whole square into T. Okay, so you just do the cross multiplication. What I am doing, sorry for this small mistake, my brain is not working after all these long hours. So mu equals to T divided by 2 pi f whole square. Okay, so if you put the value of T as 440, 2 pi f as 100 hertz, pi is 3.14, this will turn out to be approximately 0.01 kg per meter. Okay, and so therefore the total mass of the string will be mu into L, that is 0.01 kg. Okay, length is given 1 meter, so total mass will be simply the same. Okay, 1 meter you have to multiply, only the unit is different, it will be kg per meter, it will be simply kg. Okay, so now this is the end of today's lecture. If you have any doubts, any questions, don't forget to mention that in the comment section below. I will try to cover it in our future videos. So don't go anywhere, I'll be back with more videos in our channel, and if you have not yet subscribed, don't forget to subscribe, and all the best for your PU1 exams. We'll be trying to take up more videos for you, and if you have, as I mentioned, if you want something specific, please mention in the comment below. See you in the next video. Till then, bye.